All right. Yeah, good afternoon, good evening, good morning from whichever part of the world you are joining today. We welcome you to the British Society for Geomorphology Postgraduate Forum. So, we are based in UK and we run this society, which is also runs their famous journal called Earth Surface Process and Landforms. Yeah, we have been celebrating 50 years of ESPL this year. And today is a very special day. We are on World Environment Day, and we have Dr. Sajin Kumar K.S., who is based in the University of Kerala. Let me introduce him. He is an assistant professor of geology, and he earned his BSc and MSc in geology from University College Trivandrum, which is a part of University of Kerala. And from then he went to IIT Bombay, which is Indian Institute of Technology Bombay, based in Maharashtra, in India, and did his PhD. And his specialization is on landslides. On the same year, he joined the Geological Survey of India as an engineering geologist, and he was working on Himalayas and the Western Ghats of India. In 2012, he decided to go back to academics and he joined University of Kerala in the Department of Geology. He has been awarded the UGC Raman Postdoctoral Fellowship, which enabled him to take up postdoctoral research at the Michigan Technological University based in United States of America. Uh, he's also an adjunct assistant professor in the same university in the Department of Geological and Mining Engineering and Sciences. Additionally, he is also a member of the technical advisory committees of the national and the state disaster management authorities of India and of Kerala. And apart from that, he has many PhD students who have completed their doctoral studies and also masters as well. He has various international publications and a book to his credit. He's going to take us today through is a specified mobile app, which talks about how landslides can be detected or can be analyzed. Thank you, Dr. Sajin Kumar, for agreeing for this talk today. Over to you. You can share the screen, and thank you so much.
So, good evening. Yeah, as he told, good morning or good afternoon. I hope you all are able to see my screen.
Yes, we can see your screen. Thank you.
So, first of all, I thank British Society for Geomorphologists for inviting me, especially Ayyappadas, who was instrumental in inviting me, whom I know about 5-6 years before. Yeah, my topic of my presentation is a mobile-based app as an early warning system for landslides. Though this is the title, actually, rather than the theme of this presentation, 90% of my time will be discussed the background for the development of this app. What prompted me to develop this app? This is what I will be consuming 90% of the time. And that is a story, and I hope you will be enjoying that story too. Yeah. So the background is that it is 2018. So I used to deliver the same talk to even the primary school students, even to the higher politicians. And when I asked the question for what 2018 is famous, or rather notorious, the school students will say that it is a movie. Yeah. It is a movie in my local language, in Malayalam. But when you ask to anyone who is elder, they say that it is the catastrophic flood which happened in Kerala and which created havoc through the entire state. You can see this is the Cochin airport where even the taxi bay, etc., has been flooded by water. And here is the runway. And this airport has been shut down for about 10 days. And this is a road which has become as a river. And you can see people stranded in the roof, etc. So this is the flood. But the movie theme is also flood. So anyway, even the school children or any educated person, if they say about what about 2018, is that it is really the flood of Kerala. Yeah. So usually in Kerala, the average annual rainfall comes about to 3,107, and it is almost three times that of all India average. And even in the hilly districts or in the high ranges of the Western Ghats, you will have more than 5,000 millimeter rainfall. Yeah. So this is the rainfall for about 9 years from 2010 to 2018. You can see that the cumulative rainfall of 2018 is less than 2017, 15, 14, 13, 2011, and 2010. So it is higher than only 2 years, 2012 and 2016. So what happened this year? Why there was flood and no flood during this time? So I can show you the annual rainfall, the spread for every month. So this is 2017. The peak is broad. The rainfall is uniform throughout the monsoon season. But 2018 and 19 is also a year which witnessed flood, but not that much as that of 18. So you can see that there is a sharp peak because the cumulative rainfall has spanned or spilled over only for a few days, whereas the other years it is a flat peak or several minor peaks, etc., spread throughout this one. So high intensity rainfall in short duration was the result for that flood. So if you take the 2018 January as a background image, I am showing only a small part of Kerala, not the entire Kerala, only small part of the Kerala. So I'm taking this as a background image. And if you see for the entire days, because the flood occurred during the mid of August, the 15, 16, 17, you can see how much water has occupied this area when compared to this area. And this, if you keep on going for a fortnight, this is the scenario. And if you take the cumulative rainfall, this is the background value, and this is the highest peak flood time. And it shows that approximately 550 square kilometer of the area was inundated by this flood. And the result is that 450 people died. In fact, it was not the flood which have resulted in the death of 450 people. 90% of the people died because of the landslide which affected or associated with this flood. But this landslide became an unsung thing because landslide is quite common or occurs every year in this Western Ghats, but flood has occurred only rarely. That's why the 2018 means everyone talk about flood, but actually it is the landslides which killed the majority of the people. If you actually, we have mapped the entire landslides of 2018, and this is the landslide map of the entire state of Kerala. This is Kerala, this is the Arabian Sea, and here is the Western Ghats. So the eastern part of the Kerala is a mountainous region where all the landslide occurred. And if you quantify in terms, there are 4,728 landslides. Of these 700, this is not all big landslide. This is what is a small, big, medium, all the type of landslides, of which half the population is in only one district called Idiki district. Yeah. And again, half of this landslide in Idiki was in the deep forest. So we always believe that a forested area is devoid of landslide. No. Wherever or whenever the water or the pore water pressure exceeds the threshold, obviously, irrespective of the terrain, landslide can occur, provided the slope, etc., favors the landslide. So this is the scenario of our background of my work, or the theme of this work. So I will be pausing that story. I'm saying about another story, which is also another interesting one. So there occurred a landslide in a hilly terrain called Munnar, a beautiful tea estate hill station anyone can enjoy in Munnar. And this is the landslide which occurred in 2005. Yeah. So you can see that this is, I took the photograph from the crown, and this is in the year 2012. So after 7 years, you cannot identify any landslide here. This is the college building. So this is the government college Munnar. The same building you can see is that. So during this landslide, what happened is that this is a two-story building. The debris reached up to the top floor of this building. In fact, this building is the one which have hindered the further movement of the debris. So I always make it a point when I go for landslide studies, I will not restrict my travel only in the landslide area to have a holistic view or to have a vantage view. I travel crisscrossly in different direction away from the landslide. So here what I have done is that you can see a road, here one road and here one road. There is a river flowing in between. I cross this river, travel to this road, the higher road, and I have a synoptic view of this landslide. And this is the landslide. Yeah. So this is the building, college building. This is the second college building. So I will zoom this figure. You can see it here. Yeah. This is a zoomed figure. So this is the landslide, and this is the truth. This only one image have given me an insight that there is a possibility of further landslide to occur, because the thing is that above the crown there is material. Okay, there is a material. The second is that usually the crystalline are straight. Of course, there can be more than sagging in the crystalline, but here the sagging exactly coincide with this crown of the landslide. So that is the second evidence. The first evidence is there is overhang material above the crown. The second is there is sagging exactly coincides with the crown. And the third is this is a plantation where you can see that the same plantation, here it is dense, this is sparse. The sparse is because the land is disturbed, the surface area increased, so the distribution of the plantation has widened. So that is why you are having sparse vegetation here and dense vegetation here. These three field evidences prompted to say that there is a possibility of a future failure here. So with this one, I have published a paper in 2017, which is a potential headward retreat landslide site at Munnar, Kerala. And I intentionally published in an Indian journal because this has to reach the concerned people who are dealing with the landslide or the concerned people who handles the college. But that all the warning has gone to the deaf ears. And in 2018, a big landslide occurred in the same place. So my prediction came into fruition. I cannot say fruition. My prediction have come to reality, not in a positive aspect, but in a negative aspect. You can see when you compare this one, this building is this building which is collapsed. Here, irrespective of our warning, they have constructed more horizontal floors here and more buildings that have came, and even a botanical garden was constructed. And these are all governmental activities, not a private activity. Okay. And you can even see the scar of this landslide here. So such a deep scar was the earlier landslide. So you can see this was one of the biggest landslide which occurred in 2018 along with this flood. So this paper became a super hit, and because of course you all know when a storm event or a bigger event occurs, the institutions across the globe are interested to come to Kerala, and somehow they happen to read my paper, this paper, which was published earlier. And most of the people who have are interested to come to Kerala to study the 2018 flood and landslide contacted me only because of this paper. And that is how I become more visible to the global community. So there were so many institutions. So I'm coming back, stop here. And I'm coming back to the old story. So many institutions were interested to come and study in Kerala during 2018, of which, a few institutions I have mentioned here, of which one is British Geological Survey from your own land. And these two institutions immediately, since I have a collaboration with this university, they have applied for a funding to visit this area. And they got an immediate funding, that is within 2 weeks, they got a funding from National Science Foundation. So after a 10 days field work, they returned back and they have presented the findings or the reasons for the landslides in a seminar. The major finding was that we concentrated in Idiki because most of the flood and landslide occurred in Idiki. The first thing what we have done is that we have met the district collector, who is the administrative head of that particular district, and asked for the rainfall data, because once he orders, we will get the rainfall data immediately. But unfortunately, the bad thing we heard from him was that he told that 5 rain gauge stations are working there, 5 are manual, of which 4 were not working during the flood time. So only one was working, and that too in a lowland area where there is no landslide. So when they gone to seminar, they presented about the harrowing incidents in Kerala, and the Society of Exploration Geophysicists asked them, what do you want for this study area? Immediately, without any doubt, they asked for 20 automatic rain gauge stations. So they are ready to fund the 20 rain automatic weather stations. But only one thing they have asked is that your project is for 2 years, and after 2 years, who is going to handle this automatic rain gauge stations? You have to get an organization identified who will take over the landslide after your project. I, being a member of the Kerala State Disaster Management Authority, I got a letter from them stating that they will take over. But only one condition they have told is that you cannot buy the rain gauge stations what you would like to buy, but you have to buy what we prescribe, because we already have a several network of rain gauge station, and your rain gauge station also gets synced into my system. So you buy whatever we suggest. And that was too costly. So we have to finally succumb or reduce our numbers of automatic rain gauge station to 8. So we have what is an 8 rain gauge stations were installed, all in government buildings with the elevation correction, etc. We have done it, and we have, and through this one, what we have got. And of course, I too, when I present to the student community, I will always say that if you have data, you have to publish or perish. So all my findings through this 8 rain gauge station has been published as 3 different papers, and anyone can read it. It is freely available. Yeah. And with this 8 rain gauge station, what we got? We got 2 things. One is an improved rainfall data, because already 5 rain gauge station is there. With our 8 rain gauge station, it become 13. So you can understand a data from 5 and the difference between 5 and 13 rain gauge stations. And we were able to derive more refined rainfall threshold. Yeah. But the things didn't stop there. Things didn't stop there. So the unsung thing I can say, why the things didn't stop there, was that you see this landslide. This is a landslide which occurred in Kerala, which is called Pettimudi landslide, and something else about 60 people died because of this landslide. So this is the landslide. This occurred in 2021, and I have overlaid this footprint of this landslide in my landslide susceptibility map. So in this landslide susceptibility map, the landslide originated in the high susceptible zone, and it travels for something else about 2.5 kilometers. And all the people who died lived in the low susceptible zone of that area. So there is no fun in using a susceptibility map. Rather, the susceptibility map should incorporate the possible run-out zone also. Then only there will be fun. Otherwise, there is no use. You see, they consider you take into consideration this as a safe zone, and all the people lived here. So this is the sad part of this one. So I thought, why can't we propose an early warning system through a mobile app, so that the people who are living on this area, because 99% of the people uses the smartphone, so a mobile app will be a friendly one which can save the life. With this approach, then we have done so many analysis how to identify limit, and we have published in Nature Natural Hazards about this one, how to identify the flow path. So there's a different story. If I get time somewhere after 1 year or something else, I will talk about this one, how to identify the potential flow path for landslides. So with this idea, a mobile app idea, I approached my own university, which has a scheme called Innovative Project. So I have applied for this one. Yeah, university accepted it. You can go for the mobile app. And that is how far the theme of mobile app have came to my mind and started working on this one. My mobile app is baptized Slope Instability Predictor Kerala, or in acronym SLIP-K. Okay, the expansion is Slope Instability Predictor. So it is a UOK, means it is University of Kerala initiative. Yeah. So how a landslide can be mitigated? There are three possible ways. One is the hard engineering practices, like constructing retaining wall, etc., which is a costly affair. A country like India or a state like Kerala cannot venture into such practices. Or you go for soft engineering practices, even it is costly, but maybe involvement of local people may give a livelihood for them, but it is a costly affair. So the easiest way is an early warning system. Yeah. So in Kerala, how the landslide occurs, I can show you. You see, in Kerala, this is a hard rock, which is of Precambrian age, an average of 2.5 billion years, 2.5 billion years, above which you have a soil throughout Kerala, not only in a particular region. You have soil of 10 to 15,000 years. That means that there is no fine bonding between these two rock. Okay, so it is like keeping, for example, if a brick is there, if you are keeping a pile of soil, so if it is in this horizontal condition, it is stable. If it is in inclined position, it is in metastable. And what happens during rainfall, it becomes unstable. I will show you. So what happens is that if during monsoon, the water get infiltrated into the soil, and if the next day, if it is sunny, the water get evaporated. But instead of sunny days during monsoon, the rainfall prolongs and it get infiltrated. And what happens in the interface between the soil and the rock is that it will not further infiltrate because of the massive nature of this rock. Instead, it flows along the contact between soil and rock. And that is why even after rainfall, when you travel to the hilly station, you may see water dripping from the side walls to the road, etc. It is because of the water which is stored here in the soil get infiltrated and takes the path along the soil rock interface. Imagine if you construct a road here, the natural support or the equilibrium which exists has been disrupted. Or if a person construct a house, this is a common practice of constructing house in the hilly terrains in Kerala. They make a cut slope and construct a small house. So what happens is that the penultimate thing will be all the materials will be in shambles. So this is how the landslide occurs. So if you are able to identify the slope of the terrain, the soil thickness, and the rainfall which triggered this landslide, then you will be able to create a rainfall threshold. So rainfall threshold is nothing else. It is the minimum quantity of rainfall which is required to trigger a landslide. For example, imagine if this is a 2-meter thick soil, and the rainfall is about something else about 300 millimeter in 5 days have resulted in the landslide. So that will be the threshold for 5 days, 300 millimeter rainfall, 2-meter soil thickness. Imagine if in the same terrain, in 3 days, some 200 millimeter rainfall occurs, means then I can say that in the next 2 days, if there is 100 millimeter of rainfall, there is a possibility of landslide. So this is how the early warning works based on the rainfall threshold. I hope you all got it. Once again, I am repeating the same thing. This is consider that this is a 2-meter thick soil. So in 2-meter thick soil, in 5 days, 300 millimeter rainfall occurred, a landslide occurred. So that is the threshold. So in 3 days, if 200 millimeter rainfall occurs, then I can say that in next 2 days, if 100 millimeter rainfall is there, then the possibility of landslide to occur. So this is how the early warning works. Now, this is my mobile working principle. So when the rain occurs, My rain gauge station is an automatic rain gauge station, which has the capacity to telecast the rainfall every 5 minutes. So during non-monsoon, I will change into 30 minutes because non-monsoon, even if the data 00 comes also, that also will worse and my server will be crowded with the data. So non-monsoon season, I will make it 30 minutes. But in otherwise in the monsoon season, now it is tuned to 5 minutes. So rainfall occurs, my rain gauge measures the things and will be transmitted to my server. In my server, already there is a landslide susceptibility map with the rainfall threshold established. Rainfall threshold means based on the earlier landslide occurred in each 8 rain gauge stations are there in 8. So the entire district is divided into 8 polygons, 8 Theisian polygons by taking the data from each rain gauge stations. Okay. So this is how it is there. So this rainfall threshold and this rainfall will be compared and will be compared how much percentage is there. So this will be again comparing the rainfall threshold will be transmitted back and it will be come to the mobile app, a person who have installed. My mobile app is very equivalent to the Uber or Zomato or Swiggy or etc. Because if you download that app, you have to tag your location. Then in the tagging, if how the warning comes is that up to 25% of the threshold, the background image will be green. So once it crosses 25 or between 25 and 50, the color of the map changes from green to yellow, and you will get a push notification. Okay, you will get a notification. And when the threshold crosses 50 or between 50 and 75, the color changes from yellow to orange, and from 75 to 100, the color will be red. So after crossing 75, that will be the final warning. So in all color changes, you will get a push notification. I will show you. So the thing is that what happened was that this was completed in 2022. So unfortunately, after 2022, there was no landslide occurring in Idukki district because I have installed only in Idukki district, though the name is for entire Kerala because we don't have funding for the entire Kerala. So in the entire Idukki district, I have installed, but from 2022 onwards, there is no landslide. So I have to check my app, the veracity of my app, but I couldn't check because there is no major landslide. So as a fun, I started praying, even though I don't believe in God, so to have a landslide. Since my prayer is not that much sincere, I got a small 2 landslides occurred in Idukki near Munnar. So this landslide was picked up my mobile, and this is how far. So I have told for each rain gauge station, there will be a polygon. So this is a polygon controlled by one rain gauge station. Okay. So if I install more rain gauge station, I will have more Theisian polygons. The area can be divided into several small polygons. That is my future work. So from green, it become yellow when it cross 25%, and when it cross 50%, this one become orange. In between, also you can see yellow because the areas which were other areas here, when it crossed 75, it become red. And if you plot it, this is the blue line is the threshold. The threshold is something else about 55 millimeter for that time. And this was green. And when it crossed 25, it become yellow. And when it crossed 50, there is orange. And when it crossed 75% of the threshold, it become red. And if I zoom this image, because you can see that the first red came in 2nd July and till it was 8 July. So 7 days from 2nd July to 8 July, there was red there. So in 7 days, but there was only one landslide. So out of 7 warning, only one warning has become the landslide occurred. So you may think that my warning is not that much good, but I can say that any warning which has a success rate of 10% is generally considered as a better prediction because you are playing with the life. So with this landslide, I have my app proved to be a good this one. And in my app, apart from this Oduzan area, there are road networks so that even the those who are traveling through that area can also get, you can see the road, all the things getting color changes, green, yellow, orange, red, etc. So that can be used for even. And I was asked when I presented to the Saudi government, they are interested, they are constructing a rail corridor. So they want the loco pilot to have install this app so that they can get the warning if there is any landslide in there. So negotiations and all the stuffs are going on. And I have demonstrated this app during a workshop for, I think, about how many, some 34 participants were there. So I have demonstrated to them. Yeah, most of them feels that it is a handy mobile app to be used. And this is the video of my app, how you can see it. It is SlipK, and it has an option in 2 languages. When it comes to the home screen, there are few things are there which will be better than about the app I have mentioned. Then there is a glossary. If you click it, you will get the definition. Go back to home. If you click on SlipK, it takes a little bit of time because the map, because my server was not that much, because a little storage was given by my university. So running time will be a little more. Yeah. So this is the 8 rain gauge station. You will get the threshold and how much is the rainfall. And this is a day in which non-landslide day. So this is of the susceptibility map, and the background image comes up. You can zoom it to your maximum level. You'll get it. Again, go back. Here there are gallery, and even citizen science is there. Someone is interested to upload a figure, photograph, they can upload it. We will verify that one and we will launch it in the same app. So this is how my app works. And this app, though we have made it both for Android and iPhone, iOS, but it is not available now for one more. And this is published. More details you can see it here in its a slope instability predicted Kerala, a mobile web application for landslide hazard prediction in Idiki, India. So you can see more details can be seen in this paper, and you can even download the code, etc. And it is a pretty good impact factor. And even we got an Indian patent for this mobile app. And the thing is that we though we have made it for both Android and iOS, we didn't launch it in both the Play Store and the mobile App Store, because the reason is that there are so many disclaimers to be installed, because someone will use this app, and if the landslide didn't occur, as I have mentioned, out of the 7 days, only 1 day landslide occurred, he will sue me and I have to give compensation for them. And that is the first aspect. Second aspect is that in India, this is made out of our research interest, but you are not the authority to give warning to the public. Okay, so an university or myself is not entitled to give a warning. So we have kept it as such, but the Kerala State Disaster Management Authority, even the Geological Survey of India, which is the nodal agency for studying landslides in India, they are interested in getting this app, not the entire part of the app, if you because it is an interactive map, interactive app. So the app, etc., with the Geological Survey of India is a data collection app. So they are very much interested in this one. So negotiation not in the financial aspect, but in the academic and all the technical things are going on with the Geological Survey of India. And I am ready to give it for free of cost to GSI or any agency, because it is for the public or for the common man's use, I have prepared it. My what is an achievements with this app is over because I got the paper published. I got the patent, beyond which I'm not expecting anything else more because the money came from the university, not my personal fund. Okay, this is about my mobile app. I intentionally kept it 15 minutes for discussion. 5 more minutes is there. During that 5 more minutes, I would like to say something else about my lab. Rather than popularizing my department, there is no fun in delivering a talk. Okay. So I have mentioned in my presentation, we have prepared a mobile app. We have prepared the inventory, 4,728 inventory. We installed 8 rain gauge stations and all the stuffs. We have identified, I have told that we have identified the flow path for a landslide, which path a landslide prefer to go, which I've mentioned. Apart from all those things, I want to say a few things. We developed a landslide susceptibility model, which is called GIS-TISA, which means that Geographic Information System tool for infinite slope stability analysis. It is a plugin for ArcGIS. So if anyone is interested, you can read this paper and get that on download. It is very handy. You can see this one. If you are able to put this much data, you will be able to get a very good, excellent landslide susceptibility map. Then we have created a landslide atlas of Kerala. Something else about. So each chapter looks like this one. Each chapter is dedicated for a district where you will get the landslide history, landslide susceptibility map, the rainfall data, and important landslide, all the stuffs, etc. And it is available in the Geological Society of India website. It is an NGO, so I don't have any royalty. What I have prepared, I have handed over to Geological Society of India. So don't think that I am popularizing this to get the royalty. No, zero royalty. And then, of course, you all are aware about 2024. There is a big landslide occurred in Kerala called the Wayanad landslide. In the Wayanad landslide, people were stranded in the hamlets for about 3-4 days because no one do not know which are the area which was affected by landslide. So we have created a rapid assessment methodology, which are the area which are the possible to get inundated. How we have done that methodology is that by seeing the news channel, we have taken snapshots of the video and tried to correlate the location of each landslide location or the landslide affected area with the real Google Earth and plotted that location, and this much area is affected, this much area is affected. Then we guesstimated the possible source crown area, and we used the RAM software to do a modeling, runout modeling, and which have again published in Nature, Natural Hazards. And you can see the one which we have predicted is the yellow one. The real footprint is, you can see the landslide. This is a close-up view. Yellow is this one, and what is an so the interesting thing is that our model over predicted the area rather than the real one, but we didn't miss a single affected landslide. That means that our model was pretty good. So anyone who is interested to identify within 2 hours, if you have a few snapshots or a few videos of an affected area, you can use this methodology how to do the possible or a probable landslide affected areas so that you can go for rescue and all the steps, etc. And of course, not only Earth, we didn't left Mars also. Mars also, there are numerous landslide, and we were, my department is the one which have created the biggest landslide inventory for Mars. And this has published in 2022, but still we are working in several landslides on Mars. And interestingly, this came in a conference proceeding in a computer science a workshop. And the impact factor of these proceedings is something less than 43.5. Yeah, so these are the things. And here is my mobile number. Rather than calling, WhatsApp will be interesting because I always keep away my mobile when doing the work. Here is my email. Here is the website. You will see all my updates in my website. Yeah, thank you very much. And next 15 minutes is for you to ask questions.
Yeah, thank you, Dr. Sajin Kumar. It was so interesting to see such a beautiful presentation from southern part of India. Yes, so if anyone has to ask any questions, you can use the chat box. I can read that for you. Or if you want to ask any question directly, you can unmute yourself and you can ask Dr. Kumar. Uh, if there's none at the moment, if I can start asking something. So what I saw is the different debris flow that triggers these landslides, especially in northern section of Kerala. Uh, so what I'm interested to learn is, are these also related to like any flashy events? Like there's a lot of flash floods which are going on because I'm particularly interested in flash flood monitoring and modeling. So like I see a lot of flash floods and monitor those in the third desert of India. So similarly, I find there are increasing number of flash floods which are happening in other parts of India as well, especially in Himalayas, in eastern and western Ghats. Uh, so in that context, how landslides are also related to it? Just like
Fine,
give
that
us
is a
some
good
idea.
question because the latency of the updation of my landslide susceptibility map through the mobile app is 5 minutes. Every 5 minutes,
Hmm.
what is your landslide map is getting updated. So
Yeah.
even the storm event or the flash flood events can be coolly picked up my mobile. So the thing is that one should be aware of this thing. One should be closely observing this one. So otherwise, usually what happens with the normal case is that in the manual rain gauge stations, usually in India at morning 8:30 they used to take the reading, and the next morning 8:30 because 24 hours latency is there, and even the mm, GPM data also, uh, TRMM data
Yeah, it's
also,
a
they have a latency of 8 hours. So any
yes.
flash floods can be picked by this one, my app.
Mhm. Yeah, that's quite interesting. Yeah, like yeah, if flash floods are also a part of it, so
Yeah.
yeah, why not also explore flash floods in this context? Uh, yeah, so mainly, what was the main triggering event for the debris flow of Wayanad? Like, uh, what actually triggered it? It was a very intense, short-lived rainfall that happened over a few hours, and every movement came in and then washed the slopes.
1 minute.
Like I read the paper that you have published, so I was
Yeah.
quite it's quite interesting to understand.
I can show this figure to you. Yeah. You see,
Yeah.
in Wayanad, something was about 586 millimeter of rainfall in 2 days. That is, that
Hmm.
area's 9% of the rainfall occurred in 2 days.
Just
It
two
is not,
days. Wow.
yeah, not only in Wayanad, any part of the world will be affected
Hmm.
by landslide. Yeah.
Yeah. Yeah. Yeah.
Yeah, and
Uh,
even if you have a look this one, it is a
mhm,
composite landslide, I can say, because it is not a debris flow. You can see it
mhm,
is a rock slide initially, and that has been dumped here, which
mhm,
further aggravated by become a debris flow. And you can see from here onwards, you have see a widened river, this one, or landslide up
mhm,
to this one a narrow, because here there was a damming, because it was a bottleneck was there, so all the material which has been come from this place has accumulated here, and all of a sudden the artificial dam has bursted, and that is why the devastation was more. If there was no
mhm.
blockage here, it should have been a normal landslide. So these are the
Normal
two
landslide.
reasons. Yeah, these are the two. One, rainfall, and second, the geological problem. Geological problem, if you, this is how.
Yeah.
You see, this boulder has reached
Mhm,
up to a height of 50 meters from the riverbed. So this can
mhm,
come to a 50-meter high means that is only by what is a damming effect and subsequent failure of this dam. And
mhm,
I can, yeah, here is this one, a landslide. And you can see a regional view. That is, I always advise the students, don't only go to the landslide and study, have a synoptic view, vantage view. Now you can see these are big, 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 the earlier betting plane and now the lineaments, and all having a dip towards this one. Yeah.
Mhm.
So these are the reasons. The geology as well as rainfall was the real reason for the Wayanad landslide to it.
Yeah, yeah, it's quite intriguing to see something like that. So it has a domino effect. Like it happened, the natural event occurs, and then there's a dam. So
Exactly.
it is like climate and anthropogenic impact. So both
Exactly.
combine together, and that takes such massive effect.
Yeah.
Yeah, that's quite devastating, and also like so many people lost their life. The Yeah, and also to add on to another thing is how is the vegetation condition being monitored in Kerala? Like it's a part of the eco-sensitive part of India. So there's a lot of news about, like, there's a lot of deforestation that is going on. There's a lot of resorts which are popping up in, especially in Munnar, which I hear. So like how are there any like strict policy actions from the government or whatever agency who is supposed to look for that? And yeah, and I think they have a direct linkage to landslides.
There is no land use policy still available in any part of India.
Hmm.
Which type of land use can be used here, not only in the forest area, even the private land also, or in the landslide susceptible zone. Even there is no land use policy. Rather than the land use policy, I know there is a flagship program called constructing rain pits, because the agriculture department are interested in constructing rain pits because they think that that is good for their agriculture. But unfortunately, majority of the landslide, like the Kavalapara landslide, Puttumala landslide, which were the biggest landslide in 2019, occurred because of only because of rain pits. Because they do not know where to construct the rain pits. Even landslide susceptibility area also they used to construct it. So forget about this about it. So there is no land use policy. Apart from that, I hope you may be knowing, till 1980s there were without understanding the probable climatic changes associated with the land use changes. A good amount of area has been deforested. But in to compensate that one, they have done a national forest tree plantation in 1984. So those are
Hmm.
plantations like which I have shown for the Munnar area. There are plantation, the sparse and dense vegetation. There are plantation which has to be slaughtered every 20 to 30 years. Okay, so that area is more vulnerable because though it is in forest, there is forest plantations, not the real natural evergreen tropical forests. There are forest
Yeah.
plantations that will be slaughtered every 30 years. That really causes a big problem.
Hmm.
Yeah.
Yeah, yeah, quite quite reasonable to understand that. Yeah, sure. Yeah, if anyone else can go ahead. Uh,
Hi, Sajin sir. It's Ayyappadas.
Hi, Ayyappadas.
Yeah, I have like it's not a question, it's more like a doubt. So we have like 13 working rain gauge stations in Munnar now. What is the status of the rest of the state?
Rest of the district you don't have because uh, the thing is that there are plentiful of railway stations, but they were not synced together because even case Kerala State Electricity Board has their own rain gauges, irrigation department has own rain gauges, every school has their own rain gauge system, even the private tea estates have their own, but they are not synced to a common platform. That is the biggest challenge we're facing. In fact, if a drive is there from the government to sync all these things, then we should have come with the biggest one of the biggest warning. And more to that, first of all, you have to understand that all the rain gauge stations installed by the India Meteorological Department is not for landslide prediction. It is for agriculturally they installed. So, for example, Wayanad, the nearest rain gauge station is something else about 20 kilometers away. So, with that 20-kilometer away, GSI have given a warning, which is a green words and warning they have given on the day of landslide occurrence. Why not? Imagine a big landslide, one of the biggest in India, occurred in a green warning. But the real scenario is that you need localized. The easiest way is that if you look after the British Geological Survey, they have an excellent landslide map. They classify the terrains into domains. A domain means a mappable area which has unique geomorphic characteristics. So for each domain, you need a weather station. With that one, you have to create a threshold for each domain. That means each domain comes about maybe a 5 square kilometer. So similar terrains, domains are there. In other area, you don't want to what is an install a rain gauge station. Maybe you may have in a district some 100 domains, 100. So 100 different rain gauge, 100 rain gauge stations should be there. 100 threshold will be there. 100 warnings will be there. That is how you can mitigate the landslide. Yeah.
Yeah, this is also like really interesting to see because some of my friends are also working on landslides in India, on the Western Ghats and also in Himalaya. And they used to say that we have the one of the best data is coming from Kerala. But even if the data from Kerala is so sparse like this, I can't imagine how it would be in the other parts of India.
In other than Kerala, actually, Kerala, we have a very strong state disaster management authority. So they are working in very good way because I have visited several of the other state disaster management authority. Kerala is excellent in that one. So they have an excellent. They actually my rain gauge station. I was supposed to hand over to KSDMA, but till now I didn't hand over to them because I want more data, rainfall data. So every month I have to pay 5,000 rupees from my own pocket for the expense of the rain gauge stations. So similarly, there are all the tea gardens. Government have made a drive to collect the data from there. But the unfortunate thing is that it is a manual rain gauge station. So they physically enter a small digit change, etc., will create a problem. And more to that, there is a moral problem is also there. People do not know the importance of rain gauge station. So antisocial elements will just pour water also in this one. So there is no protection, etc. So that etc. is there. But any of coming years, there may be some more developments. Yeah.
Yeah.
Yeah, what I also feel is, we need more rain gauge stations everywhere in India, especially a vast country like India requires a lot of rain gauge stations. And even while I walk in Thar Desert, I find that while my river basin is on the eastern edge of the Thar Desert, and my rain gauge station is like 20 kilometers, 40 kilometers away from there, so it is useless to predict something from that. So I can't do justice while doing some data. So we need a lot of data, and there are papers who try to discuss like how ungauged river basins or ungauged areas can be done, but those are statistical problems which are being solved statistically. But again, there are some uncertainties, and we should always concern with uncertainties because you never know, the peak comes from uncertainty.
Yeah.
So,
Yes, sir. Somebody is talking.
if anyone else have anything to ask.
So more to that, actually, if some startup company comes with a low cost, what's an automatic weather station coming something else about 10,000 rupees or 15,000, then it will be interesting. Yeah. But some
Yeah,
of
sure.
Yeah, some that initiation is not coming. Actually, really, automatic weather stations are just sensors. It hardly one sensor will be 2,000 rupees. 2,000 rupees. But no one is coming out with an output. Or
Yeah.
whether they are coming with the output, it is not marketed. I do not know exactly.
Yeah, I met a startup in Indian Institute of Technology, Kanpur. So they are known as Krishnam Technologies. So I think the guy is based in Hyderabad,
Mhm.
and he has developed some ingenious river monitoring things
Rain
like
gauges
sensors.
come.
So
River
what he does
gauges.
is he put up those things on the bridge, and then he, like, if there's no antisocial element taking it away, so he protects them with a cover and places a trident over there, so it's a religious symbol, so nobody touches it. And he keeps it, and he has been helping the Central Water Commission and central other central water monitoring boards or state water monitoring boards, and they are getting good data out of that. I think similar
Excellent.
initiatives can be taken for
I
for
can say one
rainfall.
interesting story. In 2024 Wayanad landslide, about 50 kilometers downstream, one of my friend, you may be knowing, Yunus Ali Pulpadan of Iser Mohali, one of his student has inserted a turbidity meter. Not for, he didn't anticipate a landslide. Actually, he just inserted a turbidity meter, and to surprise, that landslide occurred, and the turbidity increased to 9,000 times on that particular day on landslide.
Wow.
And other surprise is that within 24 hours, that came to normalcy. That means that within 24 hours, the sediment has been transported to the Arabian Sea.
Yeah, that makes sense. Like, so there is so what we understand is slope is the main god
Exactly,
in
exactly,
geology and geomorphology.
exactly,
So
exactly.
if you have a very high slope, and then if there's a high, even there's the wash that goes in, and then everything is going out within few hours, and then
Exactly.
things can't be monitored. Similar experience I had. I had published one paper in Amarnath region in Jammu and Kashmir. So I was
Uh-huh.
trying to monitor flash floods over there, and from GPMI March, from local data, there's no data that can tell such flash flood that occurred, but it occurred. It's being reported. People have died, but no Earth observation data could actually monitor that. So that's why the conclusion was we need more automatic weather stations. We need more network of such stations in order to avoid such things in future. So, so I think there are a
Hello,
group
sir.
of people who are working. So,
Nice talking.
Yes, sir,
yeah,
sir. I have one doubt. Hello, sir. Am I
Yeah,
audible, sir?
yeah, very
yes,
much.
Uh,
you're audible. Go ahead.
yes, yes, sir. So I just want to know from you, sir. Sorna, just a minute. Sir, I just want to know that you have just said that Wayanad landslide is main reason is that about the rainfall. So I just want to know about the early warning system, sir. Is in that situation it is okay because the reason was rainfall, and rainfall can be given can be warned earlier. And so I just want to know about the status of the early warning about the landslide conditions. Is it appropriate now for the situation, or it need to more improve, sir?
There's no early warning system available. That's what I was talking. There is no early warning system for Wayanad landslide area, because the warning which they have received are given by the Geological Survey of India is from a rain gauge station which is situated 20 kilometers away. 20 kilometers away is quite further away. So that warning we cannot take it in. That is a regional warning. If you want a realistic warning, that is I was saying earlier, classify the terrain into domains. Okay, domain means a mappable area with a typical geomorphic characteristics. A slope will be there this much, soil thickness will be this much. So for that one, you have to prepare a threshold, and there you have to install a what is an this one a rain gauge station. Then only you will be able to get the warning. So there was no warning. Really, though GSI given the warning for Wayanad, there is no early warning. But depending upon the rain, there was a warning given for flood, not for landslide, because the landslide occurred in a highly elevated area. The people who died, actually earlier I have told, that has been in the plain area, the what is a low susceptible area. So in that area, they have given for warning for flooding event, but the occurred thing was landslide. I think, Manika, I answered your question.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you
Yeah,
so much, sir.
yeah.
Yeah, so yeah, I think that's interesting. The last thing that I would like to know is have you seen what are the future projection of this climate climate change induced landslides? Like there are GCM scenarios you must be aware of. So like under different RCP scenarios, have you seen how landslides would increase, or what would be the status of things which are going to happen?
Sorry, I didn't have a close observation on that one, so I will not be able to answer. Sorry for that one. Yeah.
No, no, yeah, it's just inquisitive about things like that. Um, so
I think one
Yeah, if
question is
anyone,
there. Dr. Abdul
anyone
Rahman
have,
is.
Yes, sir.
yeah, if anyone
Good evening,
else
good
have
evening,
a
sir,
question.
and the panel
Good evening.
members.
Good
It's
evening.
a very
Please,
nice
sir.
presentation. So,
Thank you very
sir,
much.
my question is, so you have your app is working very fine, but do you have any interest in updating the platform? Because we are right now in the AI-based uh, simulations. So, would it is possible to incorporate the AI modules in your existing Slip K app? Is there any sort of ideas?
Sir, the thing is that already the background images, the landslide susceptibility map, the threshold derivations, all etc. has involved AI. So the background is already AI involved is there. So that is also free to modify. If you want to use a different model, you can use it as a background. But for rain, what is this one? Threshold verification, you need only the real rainfall data coming. So there you cannot have any AI. But in the background, all the steps are working.
No, sir. The early prediction I'm saying, like to convey to the people, early prediction.
That will be tough. That will be tough. Using the rainfall threshold, it will be a tough one. Because what it is a one-to-one correlation. You don't have multiple parameters, multiple things. There is nothing else to use an advanced system. It is one-to-one threshold versus real rainfall. That correlation, please, sir. If, of course, if you have thousands of data and you have very much interlinked, then you can, if you want to use the same thing with the other area or compare that thing, etc., you can use it AI. But that aspect, we didn't came into that much level advanced because we are running short of data. We are running short of weather stations. Maybe, yeah, it is a welcome thing. We'll be thinking about it when it more rain gauge stations comes.
Yes, sir. Thank you so much.
Yeah, well, that's why I also agree. Like AI is a data quenching guy, so you need to put a lot of data to get something out, like which makes sense. Otherwise, yeah, things wouldn't work properly. Uh, so yeah,
Sorry,
I think
Jayesh, I have one
yeah,
more
yeah,
question.
please, yeah, please go ahead.
Sir, so my question is about the aborted landslide. So when I did my field work in some part of my district, Thrissur, so there were like lot of places where there like an initiation of landslide, but it was almost like aborted midway. So there is like a slip between the surfaces, but actually the landslide didn't occur. So is there some database there is about the aborted landslides or the places where there are more? Is this place is actually more prone to landslide, or as already the pressure is released, will it reduce the size, reduce the effects of landslide or the chances of future landslides there?
It is not like earthquake, the pressure is released. Actually, in earthquake, you can say pressure is released, so the possibility of earthquake is less. But here, no. Once a crack is formed, it is a potential area for failure. Okay. So it was aborted at that point of time, maybe because of two, three things. One thing is that the slope is not favorable. The second thing is that soil column is too thick, and the third is the rheology of the soil. It is not able to get fluidized to have a tendency to flow. These are the three reasons, or maybe something else like in Munnar, etc. The tea gardens, the root cohesion, etc. will bind the soil together so that it is a partially failed one. But in other Thrissur, etc., it cannot be. So, but in future, the possibility of water infiltration is more. The chances for failure in that area is more until and unless it is rectified either through covering that area with the geomembranes or refilling it or doing some hard engineering practice. It is a tough call, but you can keep on monitoring those areas by microwave data, like the method called PSNSR. So if you don't have that much vegetation, or if you have a few buildings there, then you can keep on quantifying this movement of this one, or install a GPRS. If it is a big mass, you keep a GPRS and monitor the movement of this one. If it the movement also, you can create a threshold, how much movement can result in a landslide, etc. If Joshimat, etc., you can keep on creating a threshold and do it. So only way is monitoring, or you go for hard engineering practice and stabilize that area. That is a potential area of failure.
Okay.
Yeah. So yeah, I think that's a quite nice discussion today. So I hope there's no more question. If there's, you can just unmute yourself now and ask it, or otherwise I can wrap it up now. All right. So I will take that as the finishing for this thing. So, so thank you, Dr. Kumar, for joining today and agreeing for this wonderful talk. So what I would like to conclude is like Kerala, which is also known as God's own country, has the first monsoon that arrives during this first week of June, which we have been reading throughout our school textbooks. But it also has some fragile ecosystems and human interventions in the Western Ghats, especially if we look at the different spices that Kerala makes for us and for the world. Uh, but yeah, on the other contrary, what we see today is there are different landslides which are occurring, and there's deforestation, there's some development, there's altered land use, land cover changes. So basically, today, as we are on the World Environment Day, so it's us to contemplate on our environment, and we can think about how different flashy events are increasing throughout the subcontinent and elsewhere in the world. And being a geomorphologist myself, and like other geology and earth science people, or even the hydrologists and other in greater environmental science people who are working on this, yeah, we try to build more resilience and make our future better. So on that note, the BSG Postgrad Forum, thanks everyone today, and hopefully we will have more webinars coming in on the next month. Please stay tuned to our LinkedIn and Blue Sky or whatever social media posts that you have seen, and we will also post this in YouTube soon. Thank you again, Dr. Kumar, for this webinar, and see you very soon sometime.
Yeah, thank you very much for the invitation. Yeah, thank you so
Thank you.
much. Okay,
Thank you
bye-bye.
so much. Thank you. Bye. Thank you.